Okay, we will go through the exemplar questions in the class 12 chemistry chapter 9 coordination compounds. Okay, before going through the questions, I will show you some general information. So, in this, you should know how to find the oxidation number of the elements. Okay, so in class 11 there is a redox reactions chapter. In that they are given how to find the oxidation number of the elements. So here in this coordination compound, if you take this NH3 molecule, this is a neutral ligand, that is zero oxidation number. Similarly, this carbonyl also zero, cyanide is -1, K is +1. This also is there in class 11 chemistry. Cl -1, NO2 -1. Suppose I want to find out the oxidation number of the oxidation state of nickel in this compound. So nickel plus 6 into 0, this NH3 is 0, 6 molecules of NH3 equal to +2. This is the overall charge. So now if you find out what is the oxidation state of nickel, then Ni equal to +2 it will come. Ni plus, so like this. So now NiCl4, 4Cl, Cl is -1. So Ni plus 4 into -1 equal to overall charge -2. So Ni -4 equal to -2, Ni equal to +2. Similarly, here CO2, CO8. So this CO is 0, neutral charge. 2CO plus 0 equal to, so here 0 is the oxidation state. So PTNH for this molecule, NH here 0, here -1, this also -1, and is substitute, you will get +2 as the oxidation state of this platinum. Okay. So now here to find the magnetic moment, the rule is formula is n into n plus 2, where n is the number of unpaired electrons. So suppose in the crystal field splitting energy, more means, that means the number of unpaired electrons will be less. So it will have a less magnetic moment. Okay. This is the for the octahedral and tetrahedral and octahedral for relationship. So here delta T tetrahedral equal to 4/9 delta O. So that means octahedral absorbs higher wavelength than the tetrahedral complex. Which of the following complexes formed by as a most stable? Most stable means is higher value of K means more stable. Stability constant K. Higher value means more stable. So here this is having the higher value. So that is more stable. The color of the coordination compound depends on the crystal field splitting. Okay. What will be the correct order of the absorption of the wavelength of light? So that means if it is more CFS means, so the less wavelength it absorbs. So more CF means that is higher energy and less wavelength of absorption. Okay, in the visible region they are asking. So they are given in the 15. This is the order of the splitting, that is here CO has the highest CFSC, that means it is less absorption of wavelength, less wavelength absorption. Okay, so based on that you have H2O greater than the wavelength of light. Okay, that is this is greater than this. Okay, more splitting, less wavelength absorption. And 0.1 mole of the COCl3, okay, is treated with the excess of, so we have a 0.2, that means 2 times the AgCl is formed from the input, the conductivity of the solution. So here we have to, that is 3Cl and 5 NH3, so the totally 8. you have to subtract 6. Why 6? There is a rule, I will show you. So that means that is 1:2 electrolyte. Okay, by 2452. Okay, now see here, this all having 6 valence here, secondary valence in the inside here. NH3 plus Cl plus NH6, Cl plus NH36, here only 6, so 3 is extra, this is the 3 electrolyte. Okay, so that 6 rule 6 is here, 6 groups in all, either chloride or ammonia molecules or both. Okay, here also you can see it. So when you subtract 6 there, then you will get the answer. So when you subtract 6 from here, then 2 moles, that is 1:2. When 1 mole of this is treated with the excess of, so 3 moles of AgCl is formed. So you have to subtract 3 Cl from here, so that Cl should be ionizable. So here that is coming here. So here 6, that Cl, that is a ionizable one, that will form the 3 moles of the AgCl. Okay, ionizable comes after this, so this is called counter ion also after the square bracket. I already showed you this table. You have to read that rules here, this rule and this table. Okay, this comes, ionizable comes after the square bracket. The correct IUPAC name of this compound is here. This oxidation state is given within the bracket. Here platinum have the oxidation state of 2. Okay, from that itself we can make out this is this thing. Okay, Pt plus, here this is 0 and this is -1. Okay, so 2, the here oxidation, from that we can make out this is the name. The stabilization of the coordination compound due to the selection effect is called the Sellet effect. Which of the following is the most stable? Okay, see, Sellet is only, it is done by didentate. Okay, not unidentate. Page 4. Okay, so we have this ligand again when di or polydentate. This ligand only we will do this selecting ligand. Okay, so this unidentate will not be do this selecting effect. So this is the oxalate ion and this is a didentate. So this one, this is components due to selecting effect. Which of the following is most stable? So this is the one. Indicate the complex ion which shows geometrical isomerism. Okay, that is given in the whole. Okay, so you can see this geometrical isomerism, cis and trans isomers. Okay, the crystal field splitting energy of the octahedral is given. They are asking what is tetrahedral. I showed you delta T equal to 4/9 into delta O. Okay, based on that formula you will get this answer, that is given as 60. So here this is the formula. Okay, due to the presence of the ambidextrous ligands, coordination compounds show isomerism. Okay, Polar complex. Okay, this is linkage isomers. You can go through that book. Compounds, this and this represents no say isomerism. As latent agent as two or more than two donor atoms to find it to the single, okay, which is not so here this is a monodendrite, so this won't involve in this act as a xylating agents, okay. Please don't confuse this with thiocyanate, that is different from thiosulfate, because this is monodendrite. Thiocyanate is a didendrite, okay. So this is a monodendrite, it can't be a selecting reagent. Which of the following is not expected to be the ligand, because it should share the electrons here. The nitrogen 5 valence electron, out of that already there is a positive charge, so only 4 and 4 electron is shared in the with the hydrogen, so no electron to share, so it can't be a ligand. What kind of isomerism between this and this is solid isomerism, book 11. Okay, here this they are given here. The IUPAC name of these compounds, okay, this is the IUPAC name, you can go through that IUPAC rule. The atomic number of these magnesium, iron and cobalt is given. Which of the following the inner orbital octahedral complex ions are diamagnetic? Diamagnetic means there should not be any unpaired electrons, no unpaired electrons. So you have to first to find out the oxidation state of this cobalt, okay, cobalt, iron, manganese. Then after that you have to draw this d orbital. And then based on that we have to see whether there is unpaired electron or not. 15. See now if you take cobalt, so cobalt here CO plus NH3, that is 0 oxidation state. So in this cobalt will have now plus 3 oxidation state. Cobalt have the atomic number of 27, so already plus 3 means 3 electron lost. So totally 24 electrons in this. So similarly here you find the manganese, so Mn. So here this is the state in 3, okay. So there are 22 electrons here. So here 24 electrons. So these two having the same number of electrons, 24 and 24. Here you see 18 plus 6 electrons here. So 6 electrons, they are paired, so okay, no unpaired electrons. See NH3, 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 there is no unpaired electrons, so they are diamagnetic, okay. If you take the other thing, they are all they will have the unpaired electrons, okay. So this is the d orbital, this is s orbital, okay, this 3d. Okay, these two having 24 electrons. The atomic number of this is given. See here, this is inner orbital, that is 3d itself, they are forming the compound with the NH3. The outer mean it will have 4d complexes. So we can use the same thing, but that is in the outer thing, okay. 24, 24. We see outer this Cl, these are all weak ligands, okay. So they form the outer orbital octahedral complexes. Which of the following options are correct in the Fc complex? Okay, 17. So here this is the 23 electrons, okay, because I already showed the how to find the oxidation state, okay. 20 here 3 oxidation state is 3, So 23, then 18 plus 5. There is an unpaired electron here, one unpaired electron. So it is a paramagnetic. Okay. When you have a strong ligand, that is it will allow pairing. Weak ligands, it won't allow pairing of the electrons. So there will be unpaired electrons. High spin complex means more number of unpaired electrons. Low spin means no unpaired electrons will be there. Low spin complexes. Okay. Aqueous pink solution of the copper chloride changes into deep O on addition of the HCl. This is because, see here, the tetrahedral complexes have this molecular, because based on this formula, and this is which of the following complexes are homoleptic? Homoleptic means same ligand should be there. One type of ligand, this and this. Here we have two types. Okay. 5. Okay, here what is homoleptic, one is heteroleptic they are given. Homoleptic, this is actually more than one. Identify the optically active compounds from the following. Okay, these two, book page 10. So out of this, and this is the optically active, this one. Okay, 22. Identify the correct statements for the behavior of the ethane 1,2-diamine as a ligand. Okay, it is a neutral ligand and didentate. Okay, this En is didentate. It is a selecting ligand. Okay. Which of the following compounds show linkage isomers on these two? So you can see the book. Arrange the following complexes in the increasing order of the conductivity of the solution. Okay, that is more ionizable ions. This is the counter ions. That means more conductivity. Okay, more conductivity. So here 24. 24, this is the order. Okay, so more conductivity is more ionizable here, more ionizable outside the bracket. Here we have more, this we have more conductivity than this. Two. So here, see, we have more ions here and more conductivity. Okay. A coordination compound, this precipitate silver chloride, when treated with a silver nitrate, the molar conductivity of the solution corresponds to the two ions. So the two ions will be outside of this bracket. Okay. Write the structural formula, the compound and names. 25. So this one. So here, okay. A complex of type, and this is known to be optically active. What does this indicate about the structure of the compound? So is 26. And optically active complex of indicates this 6 octahedral structure. Example they are given this. Magnetic moment, that is square root of n into n plus 2 number of unpaired electrons, is this one. Explain giving the reason. Okay, so here it is in plus 2 oxidation state. You can So there are totally 23 electrons. So Mn is 25 atomic number. So already positive 2 charge. So 2 electron remove 23 electrons. So D have 5 unpaired electrons because 18 plus 5, 18 up to uh, 3s2 3p6. So 3D will have 5 electrons. 27. The magnetic moment corresponds to the presence of I unpaired electrons in the d orbitals of M. As a result, the hybridizations involved in sp3 rather than the dsp2. Okay, thus the why are the low spin tetrahedral complexes are not formed? Now here on the basis of the crystal field theory, explain why copper 3 forms paramagnetic octahedral complex with weak ligands, whereas it forms a diamagnetic strong ligand means it allows pairing. Weak ligands it won't allow pairing of the electron. Show answer 28. The weak ligands is less than the pairing energy, so it won't allow the pairing. Okay, but so it has 4 unpaired electrons paramagnetic, while the strong field ligands that is this energy is greater than the pairing energy, it allows pairing, so it has no unpaired electron diamagnetic. 28. 18. So here you will see the strong ligand and this is a weak one. Strong means it allows pairing, weak doesn't allow pairing. (29) Because for the tetrahedral complex, the crystal field stabilization energy is lower than the pairing energy P. Give the electronic following complexes on the basis of the crystal field splitting theory. Okay, 30. So this is the one. Okay. T2G EG, T2G EG. Some of them won't have the electrons in the EG, based on whether it is the strong ligand and weak ligand. This is a weak ligand and this is under strong ligand. Explain why has a magnetic moment of this, whereas this one has a magnetic moment. 31. Involves DSP3 hybridization with one unpaired electrons. Okay, FeCN6 involves a D square sp3 hybridization with one unpaired electrons, and FeH involves sp3d2 hybridization with 5 unpaired electrons. This difference is due to the presence of the strong ligand. This is cyanide is strong ligand, weak ligand. Water is a weak ligand. Okay, weak ligand doesn't allow pairing. Strong ligand allows pairing. Arrange the following increasing or other crystal field. Okay, so this is already given in the book 15. So they are given this is the highest energy, this is the lowest crystal field splitting energy. Why do compounds having similar geometry have different magnetic moment? Okay, 33. It is due to the presence of the weak and strong ligands, because strong ligands allows pairing, so less number of unpaired electrons. If CFS is high, the complex will show the low magnetic moment and vice versa. Okay, my paramagnetic. CSO4H2 is blue in color, CSO4 is colorless. Why? CSO4H2 water act as a ligand. As a result, it causes CFSV. Hence, DD is possible in CSO4 5SO4 and shows the color. In unaided CSO4, due to the absence of the ligand, crystal spill is not possible and no color. 34. That is given in the 17. See here, CSO4 without water is white, but with water there is a CFSC taking place and this is a color. Name the type of isomerism when ambidynate ligands are attached to the central atom metal ion. Give two examples. So 35. Okay, these are the examples. 4. So we have these isomers. Nitrothiocyanate. Okay. Matching type. Match the complex ions given in the column 1 with the column 2. Okay, these colors are given. Observed color and what we see. Observed means observed by the metal ion that we can't see, and leftover color what we can see. 16. Okay, these are the two color, and this is color is what we see with our eyes, and this is the observed color by the compound. Observed and observe. And this is the options. Match the coordinated compound with the crystal central metal atoms given in the column 2. What is the correct one? 20. So chlorophyll from magnesium, vitamin B12, vitamin blood pigment from iron, vitamin B12 from cobalt. That is given in the 20. So here they are given vitamin B12 from where it is coming, cobalt, and this hemoglobin from iron, and this you can go through it. Match the complex given in the column 1 with the hybridization and the unpaired electrons. So you can find out the oxidation state and draw the d orbital diagram, then find the number of unpaired electrons, the hybridization. So this is the answer. Match the complex given the possible isomerism of the isomerism, and this is the answer. So you can find out this. Match the compounds given in the column 1, the oxidation state are present. So you can find the oxidation state. For example, I already showed you this. This is the CO is the neutral ion. So this is the zero oxidation state. Same way you can find out for the other elements. Okay. Okay, assertion and reason. Okay. So these are the options. First option means assertion and reason both are true. Reason is the correct expression. Okay. Now the toxic metal ions are removed by selecting ligands. Okay, this is selecting ligands is more stable. The components are more stable. See, both reason and first one assertion of both are true. This is the correct explanation. Are the reducing in nature. Unpaired electrons are present in the d orbitals. Option 2. Assertion and reason both are true, but the reason is not the correct explanation of the assertion. Reason is not the correct explanation. Reducing nature has nothing to do with the unpaired electrons present in the d orbitals. Linkage isomerism arises in the coordination compound containing the ambidynate ligand. Ambidynate ligands have two different donors. Okay, the correct. Complexes and this are unidentate. Do not show geometrical isomerism. Assertion is true, reason is false. Reason is false. Okay. Long answer. Using the crystal field splitting theory, draw energy level diagrams. Energy level diagram, that is orbital diagram, plus these T2G and EG. Write electronic configuration of the central atom and determine the magnetic moment. Whether if it has unpaired electrons it has means paramagnetic, no unpaired electron diamagnetic. Okay, show the answer. The magnetic moment formula is n into n plus 2, square root of n into n plus 2. N is the number of unpaired electrons. I already showed it in my notebook. 46. Okay, this is the atomic number of the cobalt. Okay, here in this we have a plus 3 oxidation state because fluorine minus 1. So C minus C1 minus 6 C1 plus 3, then plus 3 oxidation state. 27 minus 3 plus 3 means 3 electron losing, so 24. There are 6 electrons in the d orbital. Okay, coordination number 6. Okay, no problem. Okay, these 4 unpaired electrons, n into n plus 2. So this is the magnetic moment. Fluorine is the weak field ligand, so it doesn't allow pairing. Okay, so here the 2 electrons are there in that separate orbitals. Okay. For H2O, here we have this, so here only one unpaired electron, so is a neutral ligand. See here one unpaired, these two totally 3 unpaired electrons. So here 1, 2, 3, 4 unpaired electrons. So the magnetic moment. So this is a strong field ligand, see cyanide. So here see is allowed pairing. These 4 unpaired electrons get paired in the excited state. You see. So here we have a 0 electrons in this. So this is a strong ligand. Strong field ligand allows pairing of the electrons. So that is why here these 4 unpaired gets paired. So this is a diamagnetic because no unpaired electrons. Again this is a weak ligand, it doesn't allow pairing. So you have more unpaired electrons. Okay, same you can see this. Cn is a strong field ligand, it alone get paired. Okay. So now we have to use the valency band theory. Explain the following. Okay. 47. So here we have to find the oxidation number. Then 25. So here 18 plus because 3 oxidation state, so we have 22 electrons and the remaining is filled by this. Okay, inner orbital, because this pairing starts from here. This cyanide ions bonding starts from the 3D itself. That is why inner orbital complexes. Paramagnetic, there is unpaired electron, the magnetic moment n into n plus 2. So here you have diamagnetic, is also inner because it starts from the 3D. Bond pairing start from 3D. Okay, magnet, because no unpaired electron, magnetic moment is 0. So here this is also inner orbital complex. Here we have unpaired electron, there is a magnetic moment. So here you see this is the outer orbital. Here pairing is not starting from here 3D, here 4D it is having place. So this is a weak ligand. So outer orbital in 4D, this bonding is on sp3d square is coming here. So here it is not getting paired here. That is why these are occupied. Exists in two isomers A and B is okay. 48. This is the answer. Okay. What is the relation between the observed color of the complex and the wavelength of the light observed by the complex? So observed by the complex, what we see is this color, that is leftover color. 16. See, the color of the complex is complementary to which is observed. Okay, this is observed. The complementary color is the generated from the wavelength leftover. Okay, this color is the leftover wavelength. Okay, this is the observed wavelength. Okay, when white light falls on the complex, somewhat is observed. Higher crystal field splitting, lower will be the wavelength observed by the complex. The observed color in the complex is the color generated from the wavelength leftover. Okay. Why are different colors are observed in the octahedral and tetrahedral complex of the same metal and same? So because these relations, I already showed you this relation. See, this tetrahedral 4/9 into octahedral. Okay, so the higher wavelength is observed in octahedral complex. Here it is higher number will be higher for the same number. The tetrahedral. Okay.